My name's Jake Adamczyk. Today I'm going to teach you all about hot air balloons and the physics behind them. What exactly is a hot air balloon? Well, according to Google, it is a large bag filled with hot air or gas to make it rise in the air, typically carrying a basket for passengers. And I would have to say, Google is 100% right. Now, I'm sure almost all of y'all have seen a hot air balloon before, so I'm going to give a couple fun facts about them and then jump right into the juicy physics behind them, because there's a lot. First, they cost a lot to buy, about the price of a third car, anywhere from $10,000 to $80,000. And second, there's two different types of balloons. In this video, we will focus on hot air balloons, but there's also gas balloons as well. Alright, now onto the physics behind them. First, one must understand how big a balloon is. They can range anywhere from roughly 60,000 cubic feet to over 400,000 cubic feet. Now, a cubic foot is roughly the size of a basketball, so imagine 60,000 to over 400,000 basketballs inside a balloon. Now, onto the envelope of the balloon. That's the big part filled with air or gas. When a pilot uses the burner and lets heat into the balloon, it takes 3 seconds for that heat to reach the top of the massive balloon and for the balloon to react. The air in the balloon is then hotter than the air outside the balloon, which allows it to rise. In case y'all didn't know, hot air rises. Now, there's a handy dandy equation to find the lift of a balloon, and that's F sub 1 equals V times P sub C minus P sub H times A sub G. Now, hang with me here, I'll explain it all for you. The F sub 1 is going to be the lifting force, the V is the balloon volume in meters cubed, the P sub C is the density of the cold surrounding air, P sub H is the density of the air inside, and lastly A sub G is the acceleration of gravity. Now let's do a practice problem. Let's say a hot air balloon with a volume of 10 meters cubed is heated to 100 degrees Celsius. The temperature of the surrounding air is 20 degrees Celsius. The air density at 100 degrees Celsius is 0.946 kilograms divided by meters cubed. And the air density is 20 degrees Celsius. The air density at 20 degrees Celsius is 1.205 kilograms divided by meters cubed. Basically, we're going to plug in all of our information given, do some basic algebra, and get an answer. When we plug everything in, F sub 1 equals 10 meters cubed times 1.205 kilograms over meters cubed minus 0.946 kilograms over meters cubed times 9.81 meters per second squared. We get a lifting force of 25.4 newtons. But wait, there's more. To find the actual lifting force we students understand, we simply do the 25.4 newtons divided by 9.8 meters per second squared, again, gravity. This will give us 2.6 kilograms or 5.7 pounds. And special thanks to engineeringtoolbox.com for the example problem. Now there's more physics to hot air balloons. For instance, the burner which puts the heat into the balloon is more than 1 million BTUs. To put that in this perspective, your grill at home is typically 100 BTUs per square inch. That's hot. Also, the propane which powers the burner is held in pressurized containers, which are typically at 145 pounds per square inch at 70 degrees Fahrenheit. Now, to relax your brain a little after all that physics talk, here's one more quick fact to finish off this physics lesson. The first balloon was created on November 21st, 1783. That's a long time ago. Alright, well my name's Jake and that's a quick dive into the physics behind hot air balloons.